or something text which need to be stored in the database, and we want to have a tabular form of this data. So sometimes we have the data which duplicate itself so many times, and it keep on duplicating and repeating in a data set, which we should normalize it. So normalization is the process of making data more structured, more less repetitive, and more easy to read. So I am just taking one example. I will try to explain it in a as possible as easy manner. Suppose I am having first name as a column, last name, and this is a basically author information. So he has written 3 books: book 1, book 2, and book 3. So generally, if we are maintaining manual list of books and their authors, we can use this, no problem. Suppose author name is A, first name is A, last name is B, and he has written some book X, Y, and Z. Same way, we are having another author, say A2, B2, and he has written books X2, Y2, and Z2. So if I am maintaining this kind of information manually, then there is no problem. It looks quite simple and manageable. But when we are trying to store this information in the database, we will get some difficulties in making relations, obtaining some statistical report, and so and so. So what we will do, this is a kind of non-normalized or less normalized data set in terms of databases. So we will introduce one table here, and we say, okay, it is actually this is the normalized. In the not normalized form, we will use like this one. Sorry, this is a normalized. At least this is at the first normal form. What happen if I store my information on some register like first name, just name, and books? Mr. AB has written X, Y, Z, and Mr. A2, B2 has written X2, Y2, Z2. So if I am maintaining records in the paper, it is very simple and manageable, that AB has written XYZ and A2, B2 has written X2, Y2, Z2. But when we want to store this information in the database, we have some property like ACID, atomicity, consistency, durability, and isolation. So one thumb rule is that in one particular column of a particular row, we can have only one information or one data set. So if I put X as the book name value in my database, I cannot put Y as a value in the same cell, or I should not store the double value in a particular single cell. So first form, this is the first form basically. First form, first normalization, first enough we are saying in short, that we split the book name column into 3 parts, and now we are storing singular values or one value in a particular one cell. So this is our first normal form, and the idea is that store one value in a one cell. So removing the commas or the any separator we are using to hold multiple values in a one particular cell, it is known as the normalizing up to first normal form. Then in the second normal form, we will introduce more granular set of information in by the splitting the tables on the nature of information. In the second normal form, what we will do, we will introduce two table. Like we will introduce first table or first set of information, as we have discussed identifying the attributes of an entity. So in our data set, we have identified two entities. One is the person and other is the book. So in the second normal form, we will try to group all the entity, all the attributes of a particular entity in a one table. So what we have identified, that in this list we are having two entities. One is the person who written the book and other is the book itself. So we can store the information in two table. Say author, in this we will have name column and first name column and last name column. First name, because in the name column we are storing first name and last name in the same cell. So again, that is double, we are storing multiple information, or it's a multiple kind of information in a one cell. So we will make it like this, first name and last name. Now we will say this is A and this is B and this is A2 and B2. Now we will introduce one more column like ID or the author ID to identify this record uniquely. So now in the author table, one number author ID belongs to first author Mr. AB and second number author ID belongs to Mr. A2B2. Similarly, we are storing book information into book table. Again, we will introduce one more column here, book ID and book name. And here we will store 1 and 2 and 3 and 4 and 5 and 6, because we are having 6 different books with us. X, Y, Z, X2, Y2, Y2 and Z2. And we can store author ID also here. Author ID. To identify this book belongs to which author, like 1, 1, 1, 2, 2 and 2. And this form is known as the second NF. After this point, when we have first we remove duplicate double values, multiple values from a one cell to the multiple cells, is called first normalization. In the second normalization, we are splitting the tables or based on the attribute types. Okay. So this is our second normal form. Again, we can see that we are having multiple author ID repeated in the book table, and again a book is an independent entity, so we can further normalize it up to third normal form, where we will make pure mapping tables to store only mapping information, nothing else. So what will happen? Our author table is perfect. It is not related to any other table as of now. But in the book table, we are having author ID here. And that for that reason, author ID is repeated into 3 records. First, second, third, 3 book belongs to author ID 1, and 4, 5, 6. These 3 books belongs to author ID 2. So what we will do, we will, in the third normal form, just we will remove this author ID column from the book table and we will create a book author mapping. Book author mapping. Here we will put book ID and author ID. So when we move from the second normal form to the third normal form, our book table author ID will be removed, and we have to introduce one more table for just keep the book mapping with the authors. 1 2 3 1 1 1 4 5 6 2 2 2. So this is called basically normalization. So at least we should try to make our database compatible up to second NF, at least. If we are moving further and making it 3NF, rest is the BCNF. Next is the, I think, fourth NF is also there. And then when we have more multiple tables, and because of that we have to put multiple joins also. So one day will come, you will again go for the denormalization. So when we are mapping our entities and storing data into it in different tables is called normalization. And for the making of MIS reports and working with huge data set which needs huge processing capabilities, so again we are trying to denormalize it. So it's classic example like this. We are having, in general, we are having master tables in our applications and transaction tables. In general practice, we are storing all the basic, all the data set which rarely updates, like list of state, list of city, list of district. It is, these kind of information is not updating every day. So it is a master kind of information. So this type of information, then again any system information, all these kind of information are stored in a master database tables, and we keep reference of these information, these records in our transactional data. Okay, hope you have understood something, that what is the normalization. Normalization is the process of mapping attributes and entities to store in a well-defined manner in the database, so that we can easily query the data, we can join the information. And this is very much unnormalized information. This is not acceptable in database space. In the world of database, relational database management system, we cannot store multiple value in one cell. But when we do the things manually, we usually do like this only. Any question or doubt? Shahid?
Yes, all clear, sir.
ऑल क्लियर. तो प्लीज रिपीट वंस, एक बार आप रिपीट कीजिए क्या बताया.
Yes, sure. So basically, the database is basically contain the data as per the automaticity, right? So when we put the data, so suppose the book author A, B, and XYZ, the book name is XYZ, and AB and AB A2 B2 the name of the author. So when we store the data in database, it should be the first normalization. We should keep to bifurcate our first name and last name and book 1, book 2, book 3 in separate cell. So in first form, but in the second form, what we have to do, we have to create a new column in which we can write the author ID. Okay, and then we can map the first name and last name. And then for book ID, because there are two attributes there. First is book and another one is author. So in second table we can uh, we can entry the book ID and book name, and also the author ID. And in the third form we will remove the book name and we will map the book ID to author ID. So that can be easy to
Yes.
understand, that can be easy to bifurcate, or uniquely we can identify which book is written by which author.
Yes. And one more thing is that this type of work or practice is required, and you have to put lot of thought, lot of uh, practice to normalize your content. Simply, if I'm asking, okay, in the next 2 days you all have holiday and all, try to make one particular simple project like library management system or school management system or hospital management system, or suppose you daily use the metro services, so some kind of travel tour management system or bus operator management system, anything, type of relationships, type of relationship. So in the book table we are having repeated author ID. So we can say that one author is having many books. So we are having three type of relationship between the tables. First is one to one. One to one means this type of relationship usually found where we have an entity in which there is many attributes are there, and it is very difficult to store all the attribute in one table. So we generally split the table based on some common attributes set in one table and other common set of attribute in another table. But in the system, only one row will be present in both the table. So we are saying we are extending one table with the other table to keep the number of columns in a one particular table manageable. So this kind of relationship is known as one-to-one relationship. Suppose I am having just like author name, author first name, author last name. Then we are having father name, date of birth, height, weight. This type of information I am having. What I am having? I am having first name, last name, date of birth, height of the person, weight of the person, skin color. Okay. And suppose, so what do you think? How many values for a person I can have in these cells? Only one. A person can have only one name. A person can have only one date of birth. A person can have only one value for his or her height, one value for his or her weight, and only one value for color. And so. Just hypothetically think that I have so many attributes which can be only one value for a one person. I can extend it like employee ID. I can have only one employee ID for one person. Suppose department may sometime it is happening that okay, one person is working in more than one department. But for example, we can say that okay, we are having a system like this, only one employee can work in only one department. Then he will certainly have a one department code, one mobile number. Let's leave it, mobile number, leave it. Salary, one person can have only one value for his salary, and so and so. Now if I want to split the attributes, what I can say, I can say I can create two table. One is the person and other is the employee, and I will have only one-to-one mapping because the same person is somewhere employee. So personal information and official information both are related to one employee, and both the table will become kind of extended table. Personal information, employment information. So this type of table will have one-to-one relationship. Got it? Mr. X, Mr. A, Mr. B, sorry, AB is the name of the person, some date of birth, some height, some weight, some color, some employee ID 1, department code 1, salary suppose 2 lakh. Now I am just splitting the attributes or the columns based on the nature of column. So I can split personal information in one table and employment information in one table, and I can make one common value like person ID. So the person ID column will be repeated in employee table also, so that I can map this person ID with that employee ID. So this type of information we are generally storing with the multiple tables, and the tables will have one-to-one relationship between these type of two tables. Then we are having one-to-many relationship, one-to-many relationship, and many-to-one relationship. So this is actually just opposite to each other. Like in our example, we are having author and book. One author can have multiple book as of now, and one book has only one author as of now. So from the book to author, we are having one-to-many relationship, one in the author and many in the book. And from the book to author, we can say many books can be written by one author. So many to one. And then we are having the last type of relationship, that is many to many. If I am just breaking the rule that one book can be written by multiple authors, say if I am just I am storing here, it is not for the database kind of thing. 1 2 1 2 1 2 3 2 3. Again, this is unnormalized. I have to repeat the values. So for storing this thing, I can, okay, I'm just undoing it. This can happen that a book can be written by more than one author. Then we can say it is many to one and one to many, means many author can write one book and one book can be written by many author. So this is a kind of relationship many to many, and already we have created another separate table only for storing the mappings. So we can extend our this information like 1 2 2 1 2 3 is written by like this. So book ID 1, for the book ID 1, there is two authors. Book ID 1, there is two authors, author ID 1 and author ID 2. Similarly for the other two also. So we can say that book ID 1 written by two author, and author ID 1 has written three books, 1, 2 and 3. So this type of relationship is known as the many to many relationship. Now, as an assignment, think for the entities, like you are planning to develop an application for the hospital management system, then definitely you will have doctor, patient and medicine, suggested medicine, this type of entities. Now think that this is a hospital. So a patient can be get treated by more than one doctor, and certainly a doctor will treat more than one patient in a day or in this hospital. So think for the possible attributes, their data types, their length, as we have already discussed in previous sessions. Now try to identify type of relationship among the entities and how you will normalize it up to third enough at least, or up to second enough. Then try to make some sample data in your database now, because now you are able to think for the entities, you are able to think for the attributes, you are able to create a table, you are able to think for the possible data type, length, constraint, and checks also. Make the table and think for the duplicacy. If you are having repeated value, or you have to put repeated value in one column for different records, then there is chance to normalize it once again for the next level. Are you getting what I'm saying? If you are having repeated value in any column due to any reason, then there is a possible chance that you can further normalize it. So normalizing a table is not easy task. I have taken very simple example of book and author. It is a very classical example too. But when you are going in the live scenarios, real practices, you have to really hard think for the attribute, because attributes are from two type of sources are there for any attribute. One is the in general your entity things, which is tangible also. But when you come to model the processes, then finding out the attributes and then arranging them, which is the future safe also, means you have started keeping the values repeated in one particular table, and in the early days table is empty or it is having less amount of data, everything is goes very fine, no problem. But when the volume will increase and you have lot of repeated values, or you have to do lot of process to get your data back in desired form, then this is the ability of a database administrator or database architect or a good programmer who has put lot of thought to design the database. And success of an application lies in the good design of database itself. Am I right, Prasant?
Yes, sir.
Because now we can see that after having good experience, we have seen that the in the failure of applications, there are good chance that it is due to the poor database design or the poor quality of data in it. Am I right? And
Yes, sir. And that also leads to the. Yeah, go ahead.
yes, and sometime it is good for us also. Thing is that otherwise, if there is no problem in the software, then what we will do there? No, no, we should not talk like
Dugam
this.
Sagar.
This is loose type. But
Yes.
simply building a good database structure is the key thing to success of an application. I just would like to say that because I have worked with the data sets, means which has gigantic amount of information.
Also, in case of performance, it's
Hmm.
PC.
Yes, yes. In early days, when there is no record or less amount of record, everything seems fine. No problem is there. But as the data set grows, then problem begin to start.
Yeah.
And we are thinking for denormalization or using no SQL databases or adding indexes on top of the existing data. And then one day will come when this type of remedies will also not work. Indexing the things can help you to some extent. In each and every scenario, indexing is also not going to help you a lot, because when you are indexing on a huge data set and updating data again and again, all the indexes has to be rebuilt all the time, and then this will become a great bottleneck for the performance also. So putting any effort in thinking of your data set, in thinking of your good table structure, uh, right placement of relationships, right level of normalization is the key for success simply. And if you are having good database design at first place, then writing program for it is also become very easy. Okay, one more thing in this line I would like to say, consistency of the column name is also very important. It is not like that, okay, in one table I am saying it person id, and the same person id column is known as the some serial number, say, in another table, and same attribute is known as some other name in any third table. So all these kind of bad practices will leads to poor design, and then learning curve will be increased for any new joinee who will take time to understand the table structure itself. Then if we are missing the checks constraint and we are not providing adequate unique and other primary key, foreign key, all kind of this type of arrangements if we are not doing, then writing code for it is also become very difficult. So that's why we in our course we have put database topic on the top. Before understanding, before learning anything, I have selected this database understanding as a first topic, number one. So you will have adequate time when we will work with Java, and we will understand the basics of programming and then control structures and all. At that point of time, you will have sufficient spare time to deep dive into this basic concepts of database designing, table structure designing, understanding the relationships, attribute, naming convention. Everything is very important. Okay, and you have to do lot of practice for this also. So now we are moving to the next topic. Okay, joins indexing. I can say that okay, indexing is a special type of arrangement to store data in a separate space in a particular manner so that you can retrieve it fast. Okay, so typically on the primary key columns and unique columns, database management system, many database management system creates index on top of it. But during the next development, if you feel that okay, you need to query data on some other columns which is not part of the primary key or unique key, you can make index afterwards. So just like we are having create table command, we are having create index command also. So I'm not going deep into this topic now, because otherwise we will lose joins also. So in the normalization process, we have splitted our attributes in multiple attributes. Then we have splitted our table in multiple columns. tables. So when we have started, like in the top of the Excel sheet, we have data like this. Then we splitted the data into multiple columns. Then we splitted the data into multiple tables. So in the second NF, we are having two tables, book and author. But in the third NF, we are having three tables, author, book and book author mapping. Now our information is scattered and spread in multiple tables. To make a meaningful information out of these tables, we have to join them back to get the data in one row. That is known as the joins, and this is the part of our select queries. So during the selecting the information from one particular table, if the other part of this other part of our requirement is in another table, we have to make joins of those tables. So I have downloaded one picture like this to discuss this joining concept in more detail. So what is the basic requirement for SQL join? Can anybody tell what is the basic requirement for any SQL join?
Yes. So find out the data from master. Suppose we have out of 100 we have 10 employee ID, and we want a employee detail, all the detail from master sheet, so we can use join.
Hmm. So for the making joins, the fundamental requirement is that we should have more than one table, like table A and B. We may have more than one table, means we may have two tables, or we may have three tables, or we may have 50 tables, but at least two tables is required. In between, we will make a join. We will make a relationship. Okay. So if now this picture is very much clear. Select some of the fields from the table A, and the other A is the alias. In this picture, select columns from table A, and A, the next A is the alias, nickname or short name for a table name. So in SQL, generally we provides aliases to shorten the names. Then what this picture is saying, how we can get the data, common data, which is the part of both table, means find all the records which is in A and also in B. So this is called inner join. Inner join means only the common records will be fetched out, or we want to see common records in both the table. Then we will use this statement like select from table A, inner join table B, and to filter the records, we are matching the similar value from the both of the table. Column 1 of table A and column 1 of table B, or any other column. Generally this is happening when we are having either one-to-one or one-to-many relationships. Okay, so to get the common data set, we are using inner join. Similarly, I want to see all the records from the table A and attribute of the table B in which we are having similar data. Suppose I am having 10 record in table A and 20 record in table B, and this is having one-to-one relationship. It means I am having 10 records in table A, which is also part of the table B, but table B is having some additional records also. So I don't want to those additional records which is in the B table. I just want to the common record from the A, entire record from the A, and from the B only those records which is the common. Like if in the table B I am having 20 records, but only 10 records are the common from the table A, and in the table A there is only 10 records. So all the records from the table A and the common matching 10 records from the table B also. So for that we are using left join. This is normally happened when we are getting the description of the record description from the master tables. Okay, then the opposite of the left join is the right join. So just we are saying that we want to take all the records from the table B and the matching records from the table A. So instead of writing left, we are writing right, and it will display all the records from the table B and matching records from the table A. Or we can say that all the attributes from the table B and matching attribute of the similar record from table A in case of right join. This is the inverse join basically kind of thing. Means we don't want any record from the B which is also part of the table A. Select all the fields from the table A and leave the column where B is having null value. It means it will remove all the records from the table B and which is not matched with the table A also. Here what I am getting, all the records from the table A and matching attributes from the table B, and here I am getting all the records from the table A and I am just removing which is not present in the table B. So this type of where B dot key is null, we are using this type of where conditions. In above we have matched the values A dot key equal to B dot key, A dot key equal to B dot key, but here I have put one more where condition. I don't want to see any record in B which does not have matching value in A, and this is the right join, and where I am putting the same null value condition on the A key. Here I am putting the value, I am just removing the value where B is null, and in the second option we are putting where A is null. So the white portion is the removed one, only we are selecting on the orange portion. This is the Cartesian product, or get all the value from A and B, and this is only full outer join where A is also null or B is also null. So all the matching record will be removed. Unique value from the table A and unique value from the table B will be fetched out. So now we will do some practice to get value from two tables based on this type of arrangements. And we will use our similar author book table. Just 1 minute. Query tool. query. So here I am doing one thing. I am just keeping in mind that book ID is my key in the book table and author ID is key in my author table. This is I am only keeping in mind. I am not declaring author ID as the primary key and I am not declaring book ID as the primary key, and I am also not implementing any kind of uh, foreign key relationship, any kind of references. Why I am doing this thing? Because I want to get data where key is null in table A also, in first table, and key is null in the B also. If I am declaring book ID as the primary key, I cannot store null value in the book ID column in the book table. Similarly, if I am declaring author ID as the primary key in author table, then I cannot put null value in the author table. Definitely, it is the violation of standard practices that creating tables without the primary key or making references without establishing at database level. But to generate the scenarios, I have to do this. Okay, got my point? In my mind, I am thinking that okay, author ID is the primary key for the author table and book ID is the primary key for the book table. Insert into author values, author 1, author name A, last name B. This is perfect. Author ID 2, A2 and B2. This is also perfect. Now I have a author which ID I don't know as of now. This is very hypothetical data set, so bear with me. I have a very interesting author whose ID I don't know as of now. Oh, sorry, I have put not null as my regular practice. So I have to change the column definition and I have to say not null is not true. So in this way I can change the table definition also. So now interesting. I have 3 authors from which one author ID I don't know as of now. Okay, so that I can put where a dot key, that is a dot author ID, is null. Similarly, I have book and I have book author ID is 1 and book name is book ID is 1 and book name is Java. Perfect. Similarly, I have another book 2 written by same author is C language. C language. Interestingly, I have one book whose author name I don't know. Book ID 3. Say .NET. And one more thing is that I have a book author ID 2, but I don't have book ID as of now, and I have book name, say PHP. So again, I am saying, okay, where is the not null? Here is the not null. Due to regular practice, I have put not null here also. Now, what happens if I am selecting from the book? I have one book in which I don't know book ID and one book in which I don't know author ID. So if I am writing select star from author, select star from author, comma, book. How many records I will get? I can show you in author table I am having, in book table I am having 4 records and in author table I am having 3 records. In author table I am having 3 records, author table I am having 3 records and in book table I am having 4 records. So if I am not putting any join, any left join, any left outer join, right outer join, anything, I am not writing anything. I am just writing select star from author and book. How many records I will get?
4.
Ayyo. How?
12 आएगा शायद.
So,
Ah,
okay, yes.
this is called Gaussian
All.
product. Gaussian product. It means first table, first row will be multiplied or make a combination with all the records from the book table. So first author will make relationship with all the books. Second author will make relationship with all the book. Third author will also make a relationship with all the book, means all the 4 books. So I will get 12 records. See, this is the first record from the author table, 1AB, and this is come 4 times. So 1AB for the 1.1 Java, 1AB for the 1.2 see the language. One AB for the null wala book and one AB for the null wala book ID. So this way I am having all total 12 records. All the records from the first table get multiplied with the second table records. So I get, so this is what this is a kind of full join. No outer, no inner. This is full join. And this type of joins we rarely used. Can anyone give me any example where we are having this type of what I would say, this type of join? Any example? Shahid? And who else we are having? We are having Fraj, I think.
Mhm.
No, we don't have Fraj. Any kind of example where we have put this kind of multiplication Cartesian product from experience?
From table we can say, like if two table having uh,
No, no. In practical, you have seen this type of select query anywhere or any scenario where we have to write like this. We want Cartesian product, or what will be the scenario when we have this kind of Cartesian join, full join. Any example?
so in practical we can say that if the table having 10 records, right, and in table B having 20
One
records,
record. One record.
one record also you can say.
So 1
One
into 1, 10 into 1 equal to 10.
10 only. So like so, just miss.
Prashant, have you seen any example in your career where you have used Cardian product?
Unfortunately, not.
So actually this is a mathematical scenario. Okay. Mathematically it is possible. In statistics, mathematically it is possible that we can join the two sets and we will get the Cartesian product. But in practical, it is very rare we will use this kind of statement. But I have seen in my experience like this. Auth underscore id equal to 1. Sorry, I have to put character also. What is the column name? Auth id. Auth id is from author. Actually, column name is multiplied, na? AUTHOR dot auth id. So this is what? This is left join or right join?
Left join.
But this is a bad left join. Why? First we have made 12 records, then we have filtered out 4 records. Better solution like this, we use the left join so that the database is making some query path and it is preparing some way to fetch the data. So we can write the same thing like this: select star from author, left join on, sorry, left join, then table name, book on author, author dot auth id equal to book dot auth id. Then what I will get? I will not get the same record, because in my left join I am having one map with null also and one mapped with 2 also. So this is not the okay, that is the filter operation. That is not the left join. That is the filter operation. So okay, we are now moving with the our regular topic, that is the joins. So what happen if I am writing select a star from the author, left join book on author id equal to book dot author id. Same key from the both of the table I am referring in the on block of the statement, that is select a star from author, left join other table, that is the book, on the similar column available in both of the table, that is the author id. So in this way I will get all the author id, because null is also my author, all the record, 4 record from the book table and matched with the author records. Okay, I have 3 different authors who have written 4 books. So null author id matched with the null author id in the book table, and I got all the books here. Basically what I need to do to what I will get if I am writing some outer left join, anything will happen. What is this outer? Okay, I will paste this first. And what will happen if I write right join, RAGST, right? How many records I will get if I am writing right join?
Three.
Record.
Three record.
I got 4 record, but different order, because it starts from the right. 1 1, this one matched with this one, this null is again matched with this null, this 2 is again. Let me first take output of this. I am taking output of this in some notepad. Whatever is the blank is the null value. Null, here is the null, here is 2 null, this 2 is also null. This is what? Book ID. First is left, sorry, what is the first? First is left join and other is the right join. So I am getting all the record from the book table, 1 2 and null, and here I am getting all the record from the second table. Are you getting the difference? Are you getting the difference in the left join and right join? While the condition is same in our picture also, condition is same. This is what a dot key equal to b dot key, and here also a dot key equal to b dot key. Key is what? The matching column, which is present in both of the records, both of the table. But you can see that there is a difference in the outcome. Maybe the difference is in the order only. So we have to closely see the outcome. 1A, B, 1, 2, C language. 1A, B, 1, 2, C language. So first row is matching. Positions are different because the order of insertion in the author table and the order of insertion in the book table for the different authors or the whatever the values we have inserted. So joins are also affected by the insertion of the record, insertion order of the record. So this is matched. This record is available in both of the table of the both of the output. Then 1AB11 Java. This is also matched, but order is flipped. Whatever the first record we got in the first left join, we got in the first place, we got it in the second place in the right join. Then this is missing. We will see why it is missing and how to figure it out. What happened? All the value is null, but actually 3-number book author is not known, so it has put all the null values in front of book ID 3. But as we have discussed that if we are making right join, all the record from the right table will become and it will mapped with the remaining attributes of the second table, that is the other table. So in the right join, all the record from the book will come and the value will be mapped if there is a matching value for the ID. So for the book ID 3, I don't know the author ID. So all the values which belongs to the author table is put as null value. Similarly, 2, A2, B2, 2, null, PHP. This is matched. And here if I would like to say this is missing. This is the missing part. Missing if I am using left join and right join. So here see this first 4 columns from the author table. So if I am putting left join, in the left side author table is there. So all the record from the author will come and it will fill the values of the book column if it is matched in the second table. Opposite is true. All the book we have got and we got null values in place of author columns where it is not, author ID is not available. And here I got this null value, Keep an eye on this selected part because I have an author whose book I don't know, but author is there. This A3B3, Mr. A3B3 has not written any book, but due to the left join, his name comes into the output. Similarly, there is a book ID 3 whose author I don't know, but still because it is a right join, so each record from the book table have to come. So author details are missing. In the left join, Mr. A3 B3 has not written any book, so all the book information is missing in the left join and all the author information is missing in the right join. Hope it is clear for you now. ये समझ में आया? लेफ्ट जॉइन राइट जॉइन समझ में आया?
जी सर।
क्या हुआ जब हमने लेफ्ट जॉइन बोला तो ऑथर टेबल के सारे रिकॉर्ड्स आ गए और जो मैचिंग रिकॉर्ड्स बुक टेबल में मिले उनकी वैल्यू फिल हो गई। ए और बी ऑथर का सी लैंग्वेज फिल हो गया, ए और बी का जावा भी था वो भी फिल हो गया, A2 B2 का नाम से एक बुक थी जिसकी बुक आईडी नहीं मालूम थी, यस PHP वाली। देखो ए बुक टेबल में, एक सेकेंड, सिलेक्ट स्टार फ्रॉम बुक टेबल। सेकेंड नंबर ऑथर की PHP एक किताब है जिसका बुक आईडी नहीं मालूम। आउटपुट देखते हैं। PHP एक किताब है जिसका बुक आईडी नहीं मालूम लेकिन ऑथर आईडी मालूम है 2। ठीक है, तो सब आ गया। सिमिलरली जब हमने राइट ज्वाइन लगाया तो चारों बुक आ गई। पहले तो 1 2 3 एंड नल। ये देखो बुक आईडी 1 2 3 एंड नल। उसके बाद हमने देखा कि जिसका ऑथर आईडी 1 से 1 मैच हो गया तो ए बी फिल हो गया, 1 से 1 मैच हो गया तो ए बी फिल हो गया, 2 से 2 मैच हो गया तो A2 और B2 फिल हो गया। और ये जो 3 नंबर का ऑथर आईडी था ये तो बुक टेबल में था ही नहीं। 3 नंबर का जो बुक आईडी है, 3 नंबर की जो बुक आईडी है, आई थिंक यही है आउटपुट। 3 नंबर की जो बुक आईडी है उसका तो ऑथर आईडी ही नल है, तो उससे तो कोई मैच ही नहीं हुआ। ठीक है, तो वो ब्लैंक रह गया। तो यानी कि जब हमने राइट ज्वाइन लगाया तो सेकंड टेबल के सारे रिकॉर्ड आ गए और मैचिंग कॉलम फिल हो गया जिसका ऑथर में मिल गया था। और जब हमने लेफ्ट ज्वाइन लगाया तो फर्स्ट टेबल के सारे रिकॉर्ड्स आ गए और सेकंड टेबल के वो कॉलम्स फिल हो गए जिनका की मैच हो गया। तो इसलिए इन दोनों ही आउटपुट में डिफरेंस है। सिमिलरली देयर इज अ लेफ्ट आउटर ज्वाइन, राइट आउटर ज्वाइन। अभी हमने कितना देख लिया, एक सेकेंड। हाँ, वेयर बी की इज नल, ये भी करना है। A डॉट की इक्वल टू B डॉट की एंड B की इज नल एंड A की इज नल। लेफ्ट ज्वाइन में ही है। वेयर इज नल। सिंपली ऑथ आईडी अगर हम नल करते हैं तो हमारे आउटपुट से कौन कौन से रिकॉर्ड इसमें से हट जाएंगे। एक ये लास्ट रिकॉर्ड जो मिसिंग वाला था ना, ये हट जाएगा। ओ सॉरी, इज नल मीन्स व्हाट? A dot key is equal to B dot key where B, ओके ये वाला हो गया ना। फर्स्ट राइट ज्वाइन A डॉट की, लेफ्ट ज्वाइन B डॉट की। अगर लेफ्ट लगाया है तो बुक आईडी पे लगाने के लिए कह रहे हैं। बुक अंडरस्कोर आईडी इज नल। Left join on match the key from the both table and sorry मैंने भी गलत लिखा है, की तो सेम रखेंगे ना। auth id is null। जो मिसिंग रिकॉर्ड था वो आया है। दिस इज सिलेक्टेड। Select only the call record which is only present in the, I have written this one. Only select the record which is only present in the first table. Author ID is null, only present in the first table. अब ये जो बुक वाला जो पोर्शन है, आप यहां देखिए, बुक वाले पोर्शन में सारी वैल्यूज नल है। ठीक है, यानी कि एक ही रिकॉर्ड ऐसा है जिसका ऑथर आईडी भी नल है और इसका कोई बुक का इंफॉर्मेशन नहीं आया है। ये बिल्कुल अलग रिकॉर्ड है जो हमारे A3B3, दिस वन, दिस इज मिसिंग। सिर्फ अगर यही बोला जाए कि हमारे को सिर्फ वो रिकॉर्ड बताइए जो फर्स्ट टेबल में है और सेकंड टेबल में है ही नहीं। ठीक है, ये वाला मिसिंग इसमें आ गया। अब अगर हम उसमें लगा देते हैं सेकंड वाले में, राइट वाले में, राइट वाले में A डॉट की इज मिसिंग। where auth id author.auth id is null। एक रिकॉर्ड आया है, सारे नल हैं। 3.net पिक्चर में हम अपने इसमें देख लेते हैं, ये वाला 3.net। ठीक है, क्या समझ में आया? लेफ्ट ज्वाइन और राइट ज्वाइन हम तब लगाएंगे जब हमें फर्स्ट टेबल के सारे रिकॉर्ड विद मैचिंग वैल्यू ऑफ द सेकेंड टेबल चाहिए। राइट ज्वाइन हम तब लगाएंगे जब हमें सेकेंड टेबल के सारे रिकॉर्ड विद मैचिंग वैल्यू ऑफ द फर्स्ट टेबल। और ये वाला जो था वेयर कंडीशन, इसका नाम क्या था? सिर्फ यूनिक वो वैल्यू चाहिए जो पहले में अवेलेबल है। यहां पर पहले में अवेलेबल है, तो आपको जो सेकंड टेबल है बी डॉट की, उसका नल चेक करना है। यहां पर हमने पहले आइडेंटिफाई कर लिया था ना इसको, कि इस रिकॉर्ड को निकालना है और इस रिकॉर्ड को निकालना है। तो इन दोनों को निकालने के लिए क्या हमारे पास क्वेरी आ गई? एक बार मैं फिर से लिख लेता हूं इस क्वेरी को। इस वाले में ये सिलेक्ट हो रहा है और इस वाले में ये सिलेक्ट हो रहा है। ये देखिए, जब हम लेफ्ट करेंगे तो हम राइट के नल को देख रहे हैं, राइट वाले टेबल के नल को देख रहे हैं। और जब हम राइट कर रहे हैं तो हम लेफ्ट वाले टेबल का नल देख रहे हैं। तो हमें एक्सक्लूसिव मिसिंग वैल्यूज मिल जाएंगी, जो एक्सक्लूसिव इस वाले में, फर्स्ट वाले में ऐसे रिकॉर्ड जो एक्सक्लूसिवली लेफ्ट में है, ऑथर में है, बुक में नहीं है। और इस वाले में हमारे पास वो वाली रिकॉर्ड आ गए जो बुक में है और ऑथर में नहीं है। ठीक है, एनी डाउट? This is exclusive in first record, first table, exclusive in first table. And this is exclusive in second table. अगर मान लेते हैं कभी हमारे को कोई पूछे कि सेकंड टेबल या राइट टेबल के रिकॉर्ड्स ही देखने हैं, तो व्हाट वी विल डू राइट ज्वाइन with check the null value from the first table key part. What is this? How we will get? We will get is using the right join first and then check null in first table key. And what if I want to get exclusive records in the first table only, which is not available in the second table? Then what I have to do? I have to do the left join and check null in second table key. अगर लेफ्ट करेंगे तो सेकंड टेबल का की में नल चेक करेंगे, और अगर राइट करेंगे तो फर्स्ट टेबल के की में नल चेक करेंगे. ठीक है, तो इससे हमारे को क्या मिलेगा? हमारे को लेफ्ट और राइट के जॉइंस के आउटपुट में जो मिसिंग पार्ट्स थे वो निकालने में मदद मिलेगी. पहले तो हमने लेफ्ट को समझा. लेफ्ट क्या था? फर्स्ट टेबल के सारे रिकॉर्ड, सेकंड टेबल के वैल्यूज जो मैच होंगे वो फिल हो जाएंगे. राइट टेबल के बारे में हमने, राइट जॉइन के बारे में हमने क्या समझा कि सेकंड टेबल के सारे रिकॉर्ड और फर्स्ट टेबल के जो वैल्यू मैच होंगे वो फिल हो जाएंगे. इन दोनों के बीच में जो मिसिंग पार्ट्स हैं, अब मुझे वही चाहिए, तो मुझे लेफ्ट जॉइन के साथ सेकंड टेबल के की को चेक करना होगा नल के लिए, और अगर मैं राइट जॉइन लगाता हूं तो फर्स्ट टेबल के की को चेक करना होगा नल के लिए. चार चीजें हमने देखी: लेफ्ट ज्वाइन, राइट ज्वाइन, मिसिंग आउटपुट in comparison with left join and right join, and then how we'll get that missing part which was the earlier output of the left join and right join. ठीक है, याद रहेगा ये? शायद एक बार रिपीट करना, क्या समझ में आया?
हाँ जी सर.
कुछ बत्ती जली?
हाँ जी या
बताओ.
Basically, if we required all the data from left table, from first table, and we will use left join. And if we required all the data from right side and matching and common data from left from first table, then we will use right join. If we want only the common data from both of table, then we will use inner join. If we required all the data from first table but null value of the right table, then we will use left outer join. If we required all the data from second table and null value from first table, then we use right outer join.
Very good.
Full join.
And very good. And when we will put left join, left outer join, then we will check condition for the second table. इसको याद रखना बहुत जरूरी है. अगर लेफ्ट करते हो तो राइट का नल देखना है, और राइट करते हो तो लेफ्ट का नल देखना है. यहाँ देख रहे हैं, लेफ्ट ज्वाइन है तो बुक के टेबल के ऊपर नल चेक कर रहे हैं, और जब राइट ज्वाइन है तो ऑथर के टेबल पे नल चेक कर रहे हैं. ये बहुत ही इंपॉर्टेंट पॉइंट है. अगर ये जो अरेंजमेंट है ये मिस हो गया तो आपका आउटपुट भी कुछ और आ जाएगा. व्हाट विल हैपन इफ आई फ्लिप दिस कंडीशन? in this way, in this output I will get 3 records, which is this. And if I change the condition, author की जगह book कर देंगे तो I will get इसको छोड़ के, ये बीच वाला जो मिसिंग वाला पार्ट है उसको छोड़ के बाकी 3 रिकॉर्ड आ जाएंगे। तो यहाँ पर ये देखना है कि लेफ्ट के ज्वाइन के टाइम पे सेकंड टेबल का नल चेक करना है और राइट के ज्वाइन के टाइम पे फर्स्ट टेबल का नल चेक करना है। ये आपका टेक अवे है लेफ्ट आउटर ज्वाइन और राइट आउटर ज्वाइन के लिए। इस ट्रिक को भूलेंगे तो गड़बड़ हो जाएगी। ये तो कार्जियन प्रोडक्ट है, सॉरी ये तो सिंपल फुल आउटर ज्वाइन है, और इसमें दोनों का नल अगर हम चेक करते हैं, दोनों का नल अगर हम चेक करते हैं तो क्या आएगा, फुल आउटर ज्वाइन एंड देन दोनों का नल। एक बार ये देख लेते हैं फिर हम सेशन क्लोज करेंगे। select star from author and then full outer join on join book on book on author dot auth id equal to book dot auth id। ये तो की है ना हमारा, दोनों टेबल में कॉमन वैल्यू है auth id वेयर बुक का ऑथर भी नल हो एंड और दोनों अदर साइड देखना है ना, और ऑथर का ऑथ आईडी भी नल हो। इसका आउटपुट कौन बताएगा?
टू रिकॉर्ड।
वेरी गुड। टू रिकॉर्ड एंड विच टू रिकॉर्ड? मैं बताता हूँ। ये कार्जियन प्रोडक्ट निकाल लेते हैं, इसी में ढूंढ के बता देना। 12 में से ही तो 2 होंगे। ये जो 12 है ये तो मैक्सिमम कॉम्बिनेशन परम्यूटेशन है, एम आई राइट? इससे ज्यादा तो हो ही नहीं सकते। इस 12 में से कौन से 2 रिकॉर्ड?
एक का नल रहेगा।
या एक ही रिकॉर्ड, या एक से ज्यादा रिकॉर्ड?
11th एंड 12th।
नहीं, देखो हमने बोला बुक टेबल का ऑथर आईडी नल हो या ऑथर टेबल का ऑथर आईडी नल हो। तो ऑथर टेबल का ऑथर आईडी नल तो ये चारों हैं, तो ये चारों तो पास हो गए। और लगा हुआ है ना, एंड नहीं लगा हुआ है ना?
यस यस यस। सो
तो ये चारों पास हो गए। और ऑथर टेबल का ऑथर आईडी में ये तीसरा नंबर और दूसरा नंबर, बाकी 4 तो कॉमन ही थे, तो 6 रिकॉर्ड आएंगे हमारे हाथ में।
इसमें भी नल।
देखो कंडीशन जो है दोनों ऑथर आईडी पे ही है।
राइट यस यस।
बुक टेबल का ऑथर आईडी नल हो, बुक टेबल का ऑथर आईडी नल है, तीसरा नंबर रिकॉर्ड,
3rd and 7th
और 7 नंबर, या अथवा ऑथर टेबल का ऑथर आईडी नल हो, तो ऑथर टेबल के ऑथर आईडी ये सब है। तो 6 रिकॉर्ड हो गए हमारे। अयो 2 रिकॉर्ड आ गए। क्यों? क्योंकि उसका मैचिंग नहीं मिला ना, ये वाला, सॉरी मैं मिस्टेक कर गया। हमारे ये ऑन भी तो लगा हुआ है, वो कार्जियन प्रोडक्ट देख के थोड़ा कंफ्यूजन हो गया।
कॉमन।
हाँ नहीं, पर रो पे ऑथर आईडी और बुक आईडी उसका सामने का मैचिंग भी तो है। वेयर कंडीशन में हटा देता हूँ, ये 4 रिकॉर्ड ऐसे भी तो था। ऑथर आईडी 1 का 1 और नल का नल, यही तो मैच हुआ है ना। ऑन मैं भूल गया था कार्जियन प्रोडक्ट के चक्कर में।
यस सर यस।
ऑन पहले तो देखो, ऑन ने इसको रिस्ट्रिक्ट किया 5 रिकॉर्ड पे, और उसके बाद हमने बोला कि नहीं, या तो ये 2 रिकॉर्ड दे दो, या ऐसा इसके सामने ही, उसके सामने ही नल है, तो यही 2 रिकॉर्ड आएंगे। इस टेबल का ये भी था ना, दिस नल इज मैच्ड विद दिस नल।
या
Yes, so that is the common, means common null.
Common.
कॉमन नल,
Yes.
कॉमन नल। पिक्चर में क्या है? दिस इज द कॉमन नल।
Yeah.
और अगर हम इसमें फुल आउटर ज्वाइन पे वेयर कंडीशन नहीं लगाते हैं
Then all.
कौन सा रिकॉर्ड इसमें मिसिंग है? कौन सा रिकॉर्ड इसमें मिसिंग है?
It's mean full outer join on itna and itna.
इसमें देख के बताओ ना।
Which was
एक्चुअली में कोई भी रिकॉर्ड मिसिंग नहीं है।
सारे आ गए ना इसमें, फुल ऑटो फुल जॉइन है।
हमारे पास ऑथर कितने हैं? 3, 3 ऑथर है ना। 1
Yes.
2 और नल। ऑथर कितने हैं? 3, 1 2 एंड नल। और बुक कितनी है? 3, 1 2 एंड नल।
3 to 5.
नहीं नहीं, फिर वही मिस्टेक कर रहे हो कि मेरे हाथ में कितनी उंगली है। फिर मैं बोलूंगा 10 9 8 7 5 6 और दूसरे हाथ में 5, 6 5 11 हो गए।
We can use select command from book and author. So we can identify.
हाँ चलो आइडेंटिफाई। ऑथर में 3 रिकॉर्ड है, 1 2 एंड नल।
Hmm.
और बुक में 4 रिकॉर्ड है, 1 2 3 एंड नल।
Hmm.
4 किताबें हैं, नल भी तो एक बुक है ना।
So 1 2 1 2 3. 1 2 is common.
नहीं, अब ऑथर आईडी देख लेते हैं। मेरे पास ऑथर 3 ही है।
1 2 and null.
हाँ, ये तो 1 वाला जो ऑथर आईडी है वो तो रिपीट हो रहा है बुक के टेबल
Repeat
में।
order for book.
तो ऑथर आईडी 1 विद बुक आईडी, ऑथर आईडी 1 फ्रॉम द ऑथर टेबल एंड बुक का जो 2 रिकॉर्ड है जिसमें बुक आईडी 1 एंड बुक आईडी 2, उसका ऑथर तो मैच हो रहा है।
Right.
तो ये दोनों मिल के तो एक्चुअली में सिंगल रिकॉर्ड बनेंगे ना।
Single. Right.
फुल आउटर ज्वाइन में इसीलिए 5 रिकॉर्ड है, 4 इसमें है, 3 उसमें है, 7 और 2 मैचिंग
No
रिकॉर्ड है।
matching. So -7 -2 is
हाँ,
25.
तो 2 मैचिंग रिकॉर्ड कौन कौन से हैं? एक जिसका नल नहीं, जिसका नल है, मतलब ऑथर आईडी नल है और उधर भी ऑथर आईडी नल है, वो मैचिंग है। और एक वो जिसमें आपको ये मैच हो रहा है,
2.
ऑथर आईडी 1। अच्छा, इसमें बुक देख लेते हैं, बुक कौन सी नहीं आई। बुक तो सारी आ गई, 4 किताबें हैं, चारों आ गई। सी जावा पीएचपी नल एंड डॉट नेट, 5 किताबें हैं, पांचों आ गई। फुल आउटर ज्वाइन में दोनों टेबल से सारे रिकॉर्ड आए हैं, आप किसी को मिसिंग नहीं बोल सकते हैं। 1 2 एंड नल, 3 ऑथर थे, तीनों आ गए। कोई ऑथर नेम मिसिंग है इसमें? नहीं
And
मिसिंग है ना।
book में 1 2 3 null है.
हाँ नहीं, पहली बात देखो, हम इसमें क्या चेक कर लेते हैं। हमारे ऑथर टेबल के सारे रिकॉर्ड हैं, यस और नो।
Yes.
ए,
No missing record.
हाँ,
1 2 and null.
A2 A3 एंड नल, सारे के सारे हैं।
A2.
A2 A3 एंड नल।
Hmm.
और बुक में हमारे पास 5 किताबें थी, सी जावा पीएचपी नल एंड डॉट नेट। तो बी टेबल से भी कोई रिकॉर्ड मिसिंग नहीं है और ए टेबल से भी कोई रिकॉर्ड मिसिंग नहीं है। दैट इज योर फुल आउटर ज्वाइन, ये वाला। ए के भी सारे आ गए और बी के भी सारे आ गए, जो मैचिंग थे वो भी आ गए। ठीक है, और इसी में दोनों का नल चेक कर लोगे तो दोनों के एक्सक्लूसिव आ गए, जो कॉमन थे वो रह गए, मतलब जो नल वाले थे वो रह गए। ठीक है, चलो आज का सेशन यहीं पे क्लोज करते हैं। इसकी जितनी प्रैक्टिस करोगे उतना माइंड क्लियर होगा। जितनी ज्यादा आप प्रैक्टिस करेंगे, जितने ज्यादा रिकॉर्ड्स और टेबल्स और एंटिटीज के साथ, उतना ज्यादा आपको क्लियरिटी आती चली जाएगी। चलिए, थैंक यू।
Okay, thank you, sir. Thank you so much. Thanks all.
Thank you, sir.
Good night.
Thank you, sir.
Good night, sir.
Thank you, sir. Good night, sir.